look into question 3. Question 3 says like you have a figure that shows an open topped container for holding water. The container is shape of cuboid and the base of the container is 3x, the height is y, and the base of the container is a rectangle 3x by x meters, then height is y meters, and the capacity is 120 meter cube, and we need to show that the area is equals to px square plus q over x. That means you need to form an expression for the area of this cuboid. Given that the capacity, what does capacity refers to? Capacity refers to the volume of the container. Okay, so the volume of the container is 120 meter cube. Secondly, they have given you to be 3x, x and y to be the dimensions of your cuboid. The third important thing to understand is that it is open topped container. Okay, so that means there will be no top surface area, just the bottom surface area and the side surface area. So to understand this, first we need to find out what is the formula for the surface area of a cuboid. Generally for the surface area of a cuboid, your formula is 2 times length times width plus width times height plus height times length. Okay, so this is the formula for surface area. In case you have the open the top lid as well, okay, but there is no top lid, so you can just do minus what are the dimensions of it? This is 3x times x. You can do this minus 3x square, whatever you will get by this, then you will subtract this out of it. Or otherwise, if you don't remember the surface area formula, it's totally fine, because the surface area will be the sum of the surface areas of the individual sides. So we can form the formula by ourselves as well. So look into this, how you can do that. Surface area would be equals to, if you take this side, this will be parallel to the back side. So if you find the area for one side, you can just multiply it by 2. So what are the dimensions for these two rectangles? Y times 3x, because this is y and this is 3x. So we write it to be 2 times y times 3x. Okay. Secondly, if the second dimension would be these two squares. Okay, okay, they seem to be squares, but they have different dimensions. So these two rectangles have dimensions xy, so 2 times xy plus 2 times x times y. And the third, lastly, we have this face, but we don't have the top face, so we will not write for this. Just for the bottom one, it will be just 1 times 3x times x, so that will be plus 3x square. Okay, so this is how you can make, if you even don't remember the surface area formula, then you can make your surface area formula like this. Okay, just just 1 second, let me just take it down and then arrange it again. Okay, so this is your diagram and this is your surface area. The second thing is volume is 120 meter cube. So if volume is 120 meter cube, so that means you have volume equals to, what is the formula for the volume of a cuboid? X times y times, like the length time width time height, length time width time height. So what is your length width and height? One dimension is x, the second is 3x, and the third is y. So get it to be 3x square y, and this 3x square y is equals to 120. Okay. Thirdly, what will be your y be equals to? Your y will be equals to 120 over 3x square. Okay, and that means 40 over x square. Why I made this, I'll let you know. Like, if you can see your area formula, the area expression is independent of y, so that means you need to substitute back y in your original area equation. So this is the reason why I used this volume thing that they have actually given you for this reason, that you will be using it. Sorry, there was an error in this, no problem. So surface area, let's substitute back the y is equals to 40 over x square, but first arrange this, simplify this. So 3 2 times is 6x times y plus 2xy plus 3x square. Now simplify this further, it will be 8xy plus 3x square. Okay, now we will be substituting this y in your equation so that we get the required form. So 8x times 40 over x square plus 3x square, and that will give you 320. 1x will be cancelled, 320 over x plus 3x square. Okay, this is your formula for the surface area, and this is the same form, px square plus q over x. So if you rewrite this in the given form, it will be 3x square plus 320 over x. So that means that your p is 3 and q is 320. Okay, that's all. Now look into the second part. Use calculus to find the value of x for which a has a stationary value, giving you answer to 3 significant figures. Stationary value. Stationary value means whenever we need to find the stationary point. For example, if you have a curve, if it's a quadratic curve or a cubic curve, so what you will be having? You will be having either a maximum or a minimum. That means you must be having a stationary point. For this reason, you need to, if you need to find stationary value or stationary point, always you do the derivative, put it equals to 0. So here you have the derivative of the area, so you'll put dA over dx equals to 0. So let's look into this. Part B, dA over dx equals to 0 will give you the stationary point. So what is your d over dx? Derivative of this area formula, that is 3x square plus 320 over x. 3x square plus 320 over x. Put this equals to 0. So what is the derivative of, okay, we cannot take the derivative in the denominator, so first arrange this. Dx 3x square plus 320 x to the power minus 1. So the derivative would be 6x plus minus 320 x to the power minus 2 equals to 0. This will give you 6x minus 320 over x square equals to 0. Okay, so we will be getting it to be, okay, if we multiply the whole equation by x square, we will get it to be 6x cube minus 320 equals 0. So 6x cube equals 320, x cube equals 320 over 6 and that is, it will give you 53 point something, and then when you cube root both sides you will get x to be equals to 3.7641, which will round up to three significant figures as 3.764, sorry, 3.76. okay, so this is your x value. Now getting back to your question, this is your x value of your station, like x coordinate of your stationary value. Now find d square a over dx square and hence show that the value of x found in part b gives the minimum value. That means we always do this when we need to find the nature of the stationary point. We do the second derivative, and if that second derivative gives you, by putting your x value, if it gives you a positive, that's a minimum, and if it gives you a negative value, then it's a maximum. So let's check that and prove that the second derivative gives you a minimum value. Okay, so let's do the second derivative. The first derivative is this. Okay, the first derivative is this. Now we will be finding the second derivative of the same. So this is part C. So your dA over dx is this. Now if you will find the second derivative, it would be d square a over dx square. It will be 6 minus, so it will become a plus 2 times 320. Okay, just write it down in the same way. 6 minus 2 times 320 x to the power minus 3 nx n minus 1. So this will give you 6 plus 640 over x cube. Okay, your x cube value was 320 over 6, or in the your x value is 3.76. so if you substitute that back into your this, okay, you will, let's see what your value you will be getting at x equals to 3.76. your second derivative value will be, you get to be equal to 18, that is greater than 0, that is positive. So that means this means that we have a minimum okay. Secondly, one important thing, I, instead of substituting this x value, I substituted directly the x cube value over here. That gives me directly 18. Okay, so it is the best way, because the decimals won't give you the accurate value, but the fraction will give you the accurate value. Okay, that's it. That's all about your question 3. Okay, I hope you understand this all.